A single yellowfin tuna, still glistening with sea mist, can fetch thousands at a Tokyo auction if it arrives in perfect condition. From the instant it's hauled from the ocean, the clock starts ticking. Every second matters. Behind each fillet lies a race of ice, speed, and precision. How is a massive, delicate fish kept fresh across continents, through sweltering docks and freezing cargo bays? The answer reveals a world powered by cold, coordination, and unrelenting demand. Far out in the open ocean, where the horizon melts into sky, a longliner drifts patiently under the sun. On deck, fishermen move quickly and quietly. Hooks are baited with squid, then lowered into the deep, hundreds at a time, stretching for miles beneath the surface. Hours later, the reels scream to life. Yellowfin tuna, powerful and thrashing, are hauled in one by one. These aren't chaotic moments, they're clinical. Within seconds, each fish is stunned, bled, and packed in crushed ice. The bleeding reduces lactic acid buildup and preserves the color and texture prized by buyers thousands of miles away. The temperature drop begins immediately, because any delay means spoilage. Some boats carry blast freezers reaching -60 degrees Celsius, locking in freshness for frozen exports. Others rely solely on ice, racing the fish to shore before degradation begins. The choice between freezing and chilling isn't just technical, it defines the fish's destiny. Frozen tuna often ends up canned or used for cooked dishes. Chilled, unfrozen tuna is headed for premium markets in Japan, Europe, and North America, where color, texture, and temperature determine price. Once the hold is full, the boat turns toward port. Manta in Ecuador, General Santos in the Philippines, Suva in Fiji. At the docks, forklifts unload the catch into refrigerated warehouses, where another transformation begins. Tuna are sorted by size, weight, and fat content. Exporters inspect the meat by cutting into the tail, gauging its deep red hue and gleam. The highest grade fish are labeled for air freight. These fish are cleaned, vacuum sealed, boxed with cold gel packs, and moved into cold storage until flights are ready. At this point, speed becomes everything. For fresh tuna, even an hour in the wrong temperature can mean discoloration or bacterial growth. Flights are coordinated to align with demand windows at major fish markets. Tokyo's Toyosu, Paris's Rungis, New York's Fulton. Cold chain logistics take over. Every crate is tracked, every temperature recorded, every delay mitigated. Fresh yellowfin is loaded onto planes under strict thermal controls, while frozen shipments head to cargo ports in refrigerated containers. Reefers designed to maintain deep freeze conditions across oceans. Even on land, the journey remains perilous. Trucks carry temperature-controlled cargo across hot coastal roads, navigating customs inspections, traffic delays, and inconsistent infrastructure. In West Africa, poor road conditions mean reefers are sometimes transferred to boats that follow the coastline to avoid overland breakdowns. In island nations, yellowfin might pass through multiple hands, ports, and warehouses before export. At each stage, the fish must remain between 0 and 4 degrees Celsius, or below -18 if frozen. This delicate threshold protects both safety and value. As the tuna moves from ocean to cargo hold, from dock to depot, it's tracked with barcodes, sensors, and sometimes even satellite tags. Because freshness is money. Because a yellowfin that's even slightly too warm might still be edible, but no longer elite. And in the world of high-grade tuna, there's no room for second best. Yet for all the cold storage and careful handling, a far greater challenge waits ahead: the relentless unpredictability of global movement. In a refrigerated container floating through the Panama Canal, 20 tons of yellowfin tuna rest on steel racks chilled to perfection. Outside, tropical heat presses against the metal walls. Inside, a digital sensor blinks every few seconds, recording humidity and temperature in real time. If this number rises even slightly, if the airflow shifts or power fails, the entire load is at risk. One disruption, and thousands of dollars melt into waste. That's the tightrope the tuna industry walks every day, keeping 6 million tons of perishable protein in perfect condition while crossing oceans, borders, and climates that care nothing for freshness. The cold chain, though invisible to most, is an empire of vigilance. Airports, seaports, warehouses, and trucks form a delicate network that spans the globe. Tuna meant for fresh consumption must never leave a strict temperature window. A delay in a customs haul, a lapse in refrigeration, or even a power cut at a transfer station can introduce enough fluctuation to dull color and degrade texture. That's why many logistics companies now rely on real-time tracking systems, thermal sensors, GPS modules, and cloud-linked monitors that alert managers the moment conditions stray from safe zones. In Singapore, a logistics coordinator stares at a wall of screens. One shows a shipment from Colombo that's due in Frankfurt. Another tracks a container en route to Los Angeles, caught in a tangle of port congestion. Each blip on the screen is a living product, whose value drops with every hour spent unmonitored. The coordinator adjusts routing instructions, requests emergency ice reloads, and reroutes containers based on sudden airport closures. There's no room for guesswork. The system operates in hours, not days. Complications compound quickly. Tropical storms can delay shipments by days. Political unrest might shut down a key customs checkpoint. A single miscommunication, wrong paperwork, misread time zone, mishandled cargo can erase months of work. In Ghana, a truck's refrigeration system fails mid-transit, spoiling 2 tons of yellowfin before it reaches port. In Peru, an airport workers strike grounds flights for 48 hours, leaving crates of tuna on the tarmac under the rising sun. Every incident costs, not just in money, but in reputation and consumer trust. Then comes regulation. Countries demand strict standards on seafood imports, parasite testing, mercury limits, traceability audits. The European Union enforces catch documentation schemes, while the United States requires transparency on vessel operations to combat illegal fishing. For exporters, this means managing not just ice and transport, but endless documents, inspections, and verifications. And yet, despite the complexity, the trade continues to grow. Demand climbs higher, markets expand. Sushi restaurants multiply in cities that once barely touched raw fish. All this while climate volatility tightens its grip. Heat waves increase spoilage risk. Rising ocean temperatures push tuna into deeper or more distant waters, complicating fishing routes. Ice becomes more expensive. Cold storage demand spikes. Ports become overburdened. Infrastructure lags behind. And the whole system strains under the pressure of feeding a global appetite with a product that begins dying the moment it's caught. Still, the trade doesn't stop. It adapts. Because behind every tuna auction, every fillet on ice, every dish placed gently before a customer, lies a cold chain more precise than a clock. But as the limits of that system are tested, innovation becomes not a luxury, but a necessity. In the world of yellowfin tuna, innovation is not a luxury. It is the price of survival. As global demand intensifies and environmental pressures mount, every link in the supply chain has been forced to evolve. What once depended solely on ice and instinct now runs on sensors, algorithms, and satellite feeds. The industry that moves yellowfin across oceans has become a digital organism, constantly adapting, reacting, and recalibrating. Cold is no longer enough. Now, control must be absolute. Inside a modern reefer container, embedded sensors measure not only temperature and humidity, but vibration, oxygen levels, and even the frequency of door openings. These micro-devices, often smaller than a deck of cards, transmit their readings to logistics centers thousands of miles away. If a container sitting in a port in Manila shows a 1-degree temperature spike, alerts flash on screens in Amsterdam, Tokyo, and Los Angeles within moments. A dispatcher reroutes a truck. A logistics officer makes a phone call. A backup refrigeration unit is activated. There is no panic, only programmed precision. Each fish, each crate, Each shipment is now a data point, part of a larger system that never sleeps. What makes this system extraordinary is its invisibility. Consumers rarely see the lattice of coordination beneath their plate of sashimi. They do not think of the temperature fluctuation that almost compromised the fish during a power outage in a transit hub. They never hear the tense phone calls between customs officers and exporters when documentation gets delayed. And yet, these invisible tensions shape the final product. The smoother the supply chain operates, the more seamless the experience for the end user. But behind that elegance is a network of technological tensions stretched taut. Blockchain has introduced a new layer of accountability. For years, consumers had no way to know where their tuna came from, how it was caught, or by whom. Now, with traceability platforms built on blockchain, a restaurant can scan a QR code and instantly access the fish's entire history. Catch date, vessel name, fishing method, temperature log, transit route, inspection records. Some systems even include video from the boat or interviews with the crew. It's not just data, it's identity. And in a market increasingly conscious of sustainability, identity sells. Tuna without a story is now seen as suspect, or worse, untrustworthy. These digital records also help combat illegal, unreported and unregulated fishing, a massive problem in the yellowfin trade. Satellite monitoring combined with artificial intelligence can detect suspicious vessel behavior, such as erratic movements or signal silence near protected zones. NGOs and government agencies use these tools to flag potential violations and respond faster than ever before. A ship that used to slip through regulatory cracks might now find itself confronted by port authorities before even docking. Yet, technology isn't limited to enforcement. It's reshaping how yellowfin is caught. Predictive modeling based on sea surface temperatures, chlorophyll concentrations, and historical migration patterns allows fishing vessels to locate tuna schools more efficiently, reducing fuel use and bycatch. These models are fed by satellite data and refined by AI that learns with every trip. In the past, captains relied on instinct and weather radios. Now, they consult predictive heat maps and machine-generated catch forecasts. The ocean hasn't changed, but the way it's read has. Back on land, cold chain infrastructure is undergoing its own transformation. Ports in Pacific Island nations, once plagued by inconsistent electricity and aging equipment, are now experimenting with solar-powered cold storage units. These hubs allow small-scale fishers to chill their catch locally before aggregation and export. For communities previously locked out of high-value markets, cold storage means access. It means selling yellowfin, not just to local buyers, but to international traders demanding strict thermal consistency. With better cold storage comes better pricing, less waste, and more autonomy. Some freight companies are pushing further, offering carbon-neutral seafood shipping. They calculate the emissions generated by transporting tuna by sea or air, then purchase verified offsets, such as reforestation projects or renewable energy investments, to balance the equation. For premium buyers, this kind of transparency is becoming part of the purchasing decision. A high-end restaurant in London may now ask not just about the fish's texture or origin, but also about its carbon footprint. In this new market, ethics and logistics are intertwined. Even consumer experience is evolving. Supermarkets in France, Japan, and the United States are piloting smart packaging. Boxes that change color if the tuna inside is exposed to unsafe temperatures. These visual cues, triggered by chemical indicators, are designed to reassure customers while signaling when a product is no longer fresh. It's one more layer of control in a supply chain where information equals value. But not all innovation is digital or high-tech. In Tokyo, some elite sushi chefs insist on tuna caught by traditional handline or spear. These methods reduce stress on the fish, avoiding bruising and lactic acid buildup. Once caught, the tuna is packed in oxygen-reduced containers and flown within hours to ensure peak freshness. These fish can fetch extraordinary prices, not because of their volume, but because of their handling. It's a fusion of ancient technique and modern logistics. old world quality preserved by new world systems. Meanwhile, in research labs from San Diego to Singapore, scientists are experimenting with lab-grown tuna, cultured cells grown in bioreactors designed to mimic the taste and texture of real fish. Though still in early stages, this technology promises a future where yellowfin can be produced without boats, nets, or bycatch. It's not a replacement yet, but it is a signal that the industry, for all its complexity, must keep adapting. The logistics of yellowfin tuna are no longer just about movement. They're about information, accountability, and constant adaptation. Every advancement from a solar-cooled container to a blockchain-traced fillet is a response to a world that demands more precision, more transparency, and less waste. Behind each shipment lies a dynamic system in flux, one where tradition and technology are not at odds, but co-conspirators in keeping the tuna trade alive. That perfect slice of yellowfin didn't arrive by chance. It moved through ice, tech, and human care, preserved by precision and instinct. Every bite carries the weight of oceans and innovation. If that amazed you, click the next video to uncover more of the world behind your food.